It's a blistering 34.7 degrees Celsius at our testing facilities here in Ohio. It's about 94 degrees Fahrenheit for all my American friends. And while the temperatures outside might be scorching, inside this S19J Pro, it's a totally different story. Thanks to this hybrid cooling system, as well as our direct-to-chip liquid cooling blocks, we're able to keep this S19 running at an extremely cool, even and consistent temperature. We're currently hashing at default settings on this 104 terahash model, pulling approximately 3.34 kilowatts at the wall, including this entire cooling system. And although the ambient temperature is approaching 35 degrees, the hottest temperature inside this amp miner is a cool 45 degrees Celsius. And as you can see, the difference in temperature between the hottest and coldest sensors inside this unit is a mere 6 degrees Celsius. Now those temperatures might sound insane for a hot environment like this, and it's because they are. But in this video, we're gonna break down what hybrid cooling is and how our patent-pending cryo blocks, combined with a hybrid cooling system, allows miners to achieve some of the best and most efficient cooling, even in extreme conditions. We've cut the power, we've cranked up the AC, but before we dive into hybrid cooling, let's take a step back and discuss why cooling is so important in the first place. It all boils down to one word that I'm sure you're familiar with: efficiency. Now, proof of work mining is an extremely competitive industry. It's a free market that anybody, anywhere, at any time can join. Network difficulties continue to increase. Newer, more efficient miners are always being introduced. Established mining operations gobble up cheap power. And if all that wasn't bad enough, every 4 years or so, your revenues get cut in half. All of this points to efficiency being one of, if not the most important metrics a miner can track. But efficiency is not just your joules per terahash. It's every aspect of your mining operation. And that's exactly where cooling comes in. Proper cooling isn't just an accessory to mining. It's one of the most critical factors that determine your efficiency and success. Efficiently cooled miners operate at peak performance for a longer lifespan with less downtime, fewer maintenance issues, and they consume less power than those miners running at higher temperatures. So in an industry where every penny and watt count, keeping your miners running cool can mean the difference between profit and loss. So if you're looking to dial in efficiency and profitability, optimizing your cooling is one of the best places you can start. We've engineered these direct-to-chip liquid cooling blocks called cryo blocks, as well as a hybrid cooling method to prioritize efficiency. By providing the extremely cool, even and consistent temperatures that you just saw, we drastically reduce the amount of energy that these miners consume, while also reducing the thermal stress they experience. This leads to a reduction in our energy costs, as well as potentially longer lifespan, higher uptimes, and less maintenance. And as we'll discuss, we're able to provide that extreme cooling, all while reducing the infrastructure, saving you on both capital and operational expenses. So let's talk about hybrid cooling. Hybrid cooling combines the power of both liquid cooling and air cooling to give you optimal temperatures and performance. You see, water is great at cooling large, dense loads of heat, like the heat created from your ASIC chips. But water is not good at cooling the low-grade residual heat created from other components and heat that is spread to other areas of the hashboard. Now, air cooling is the exact opposite. It is not good at cooling large, dense loads of heat, but it's great at removing that low-grade heat created from other components, as well as heat that accumulates on other areas of the hashboard. And when you combine both of these cooling methods, you get the best of both worlds. Our specially designed cryo blocks make direct contact with the ASIC chips, quickly absorbing and removing all of the dense heat. Then a slight breeze is pulled through the miner from the back fans, removing all of the residual heat that typically accumulates. In addition, it provides another layer of cooling to the backside of the ASIC chip. These two cooling methods interact to give you some of the lowest, most consistent and even cooling across all of your chips. It's no wonder then why next generation data centers, like those used by NVIDIA and other AI companies, are beginning to utilize hybrid cooling in order to manage their thermal demands. At CryoByte, we're providing almost all of the same benefits for proof of work miners. Now, the backbone of this hybrid cooling system is the cryo block. As you can tell, this direct-to-chip liquid cooling block is not your typical water block. It features 3 ports that allow us to optimize the flow of your coolant. In addition, we're able to reduce the amount of pressure needed to pump your coolant. This lets us target and eliminate hot spots while also decreasing the size and the energy consumption of your coolant pumps. We're also able to manipulate the flow of your coolant to run either from the front to the back or from the back to the front of your hashboard. Quick nerd out. Your efficiency in cooling is largely dictated by the difference in temperature between your hot load and your coolant. The larger the difference, the better the cooling effect. So in a hybrid cooled unit, we're able to move cool water from the back to the front of the hashboard while pulling cool air from the front to the back of the miner. This creates a cross cooling effect that targets and eliminates hot spots while also providing some of the most even temperatures. That's why sensors throughout this unit are almost the exact same temperature. Now we don't just stop there. The internal structure of the cryoblock has been optimized to greatly increase the surface area. This increases the rate of heat transfer from your cryoblock into your coolant. We also use a thermal paste that is 2 to 3 times more thermally conductive than your standard thermal paste. All of this allows heat to be quickly removed from the miner and rejected through a final unit like a radiator, dry cooler, or water tower. We've also made additional improvements to the cooling blocks. We utilize what's called a barb and compression fitting. This fitting type has been used for decades in many industries that require high performance. Industries like automotive and high performance computing. By utilizing the barb and compression fitting, we are able to create a single piece manifold hose design using EPDM tubing. This eliminates a lot of the points of failures that you see in traditional water-cooled miners. EPDM is known for its resistance to high temperatures, as well as acids and other chemicals. It's flexible, it doesn't deform, it doesn't crack, and it doesn't leach plasticizers into your cooling loop, which can degrade performance over time. All of these improvements, combined with the efficiency of hybrid cooling, create an extremely high-performance cooling system. So much so that we're able to utilize a process called hot water cooling. Hot water cooling is exactly what it sounds like. It utilizes an elevated coolant temperature, and because of the temperature difference between our coolant and our ambient air, our final heat rejection unit is able to operate much more efficiently. And if you remember from hybrid cooling, as air moves through the miner, it provides an additional cooling effect, further reducing the size and operational expense of our final heat rejection unit. Man, that was a lot. But it's time for us to put our money where our mouth is. We're gonna conduct 3 tests that show you in real time the performance of our cryoblocks combined with the hybrid cooling system. The first test will highlight the minimum cooling we need, comparable to another cooling solution. This will highlight the energy efficiency of this entire system. It'll also highlight how we can greatly reduce the noise because all of our fans are operating at a very low speed. The second test is gonna showcase our maximum cooling. We're gonna crank everything up and show you how cool we can keep this unit even in an extremely hot environment. The third test is gonna highlight the flexibility of hybrid cooling. We're gonna balance both the liquid cooling and air cooling loops to provide consistent temperatures across every hashboard. So let's get started. Our first test is minimal cooling. We jump in at the 55-minute mark, but we'll fast forward to the end of the test just to show you the consistency in temperatures across time. Our back fans are running at only 10% power, while our radiator fans are running at 20% power. As we get to the end of this test, you'll see that the maximum temperature inside this unit is 65 degrees Celsius, while the ambient temperature is 37.4 degrees Celsius, which is over 99 degrees Fahrenheit. The difference in temperature between our hottest and coldest sensor is only 8 degrees Celsius. The final data from this test is as follows. The overall power consumed from all of our cooling was less than 70 watts, while the decibel levels were below 60, similar to that of background music. Test 2 is maximum cooling. In this test, we again jump in at the 55-minute mark, and we'll fast forward to the end of the test, highlighting the consistency in temperatures. We have our back fans running at 100%, and our radiator fans running at close to 100% as well. As we get to the end of the test, you'll see that the maximum temperature inside this unit is only 48 degrees Celsius, while the ambient temperature is 36.5 degrees Celsius, which is over 97 degrees Fahrenheit. This is an extremely cool temperature for such a hot environment. And the difference in temperature between our hottest and coldest sensors was only 7 degrees Celsius. The overall data from this test is as follows. Our maximum temperature inside the unit was only 48 degrees Celsius, while our ambient temperature was an elevated 36.5 degrees Celsius. This shows how cool we can keep these machines even with elevated temperatures. It also highlights how important cooling is for the overall efficiency of your operation. Test 2 consumed less power and had a higher efficiency compared to Test 1, even though we used more energy to cool the miner. Test 3 is balanced cooling. We jump in at the 55-minute mark and we'll fast forward to the end of the test. Our back cooling fans are running at 1% power, so almost all of the cooling in this test is being provided by the cryo blocks. As we get to the end of the test, you can see that the highest temperature inside this unit is a cool 56 degrees Celsius, while the ambient temperature is 36.3 degrees Celsius. The difference in temperature between the hottest and coldest sensor on this miner is only 5 degrees Celsius. The data from test 3 is as follows. This test gives us two key takeaways. The first is the overall efficiency of the cryo blocks. Even at these elevated temperatures, we were able to provide extremely cool, stable, and almost perfectly even thermal conditions across all of our hash boards. The second key takeaway is the flexibility of the hybrid cooling method. As a miner, I can provide extreme cooling when needed, such as during peak operational loads or in hotter environments, but I can also scale it back to conserve energy when temperatures are lower or when my cooling demand is reduced. This adaptability ensures that my mining equipment runs efficiently and reliably around the clock, adjusting performance based on real-time needs. This allows me to have optimal cooling and efficiency in any environment, any season, or any market condition where I might want to overclock or undervolt my miners. Today we've shown you a lot, specifically how hybrid cooling works and how our specially designed cryo blocks can allow miners to achieve some of the lowest, most efficient, even, and stable chip temperatures available to proof-of-work miners. These blocks ensure that your miners run cooler with greater reliability, helping you maximize your efficiency, performance, and overall profitability. If you're interested in using this technology, or if you'd like to discuss any other aspect of proof-of-work mining, we would love to connect with you. We really enjoy talking to miners of all shapes and sizes, so please reach out to us via our website, email, give us a call, or connect with us via one of the social links below. And make sure you like, subscribe, or follow to stay in the loop.